Today, we're diving into a really fascinating predictive model. It basically maps out our entire global energy transition over the next 30 years. It's a journey into one possible future, and it's a wild one, so let's get right into it. But let's kick things off with a huge question, one that really frames everything we're about to talk about. What if we are, right now, on the verge of an era of essentially infinite energy? What would that world even look like? And, how would we even get there from here?
So, what we're looking at here is a detailed 30-year timeline, and it's broken down into 3 totally distinct phases. Think of it as a roadmap charting humanity's path from a world of energy scarcity to an age of genuine abundance. And it all starts right now.
All right, the journey kicks off with the first decade. This phase is all about smart electrification. And this is where artificial intelligence and some seriously advanced batteries become the, unexpected heroes of the story. They're going to completely rewire how we think about and manage power. Just take a look at this timeline. The model predicts that by 2026, AI energy managers in our homes will be mandatory. We're talking software that negotiates our electricity prices in milliseconds. This then paves the way for the explosion of virtual power plants, which leads us to this massive tipping point for solar in 2030. And by 2033, even our cars are part of the grid. It's an incredibly fast, intelligent evolution. So that brings us to these things called virtual power plants, or VPPs. I want you to picture this. Millions of home batteries, like the one in your garage, all connected by AI, acting like one single, gigantic power plant. They can sell their stored solar energy back to the grid when everyone gets home from work and turns on the AC. It turns every home into an active player in the energy game.
And here is the real kicker, the economic engine driving this whole thing. By 2030, the prediction is we hit this crucial tipping point. The cost of building brand new solar panels plus battery storage becomes cheaper everywhere in the world than building any new fossil fuel plant. At that point, the transition isn't just a good idea for the planet, it's economically inevitable.
And this tech gets woven right into our daily lives. By 2033, with something called vehicle-to-grid becoming standard, your electric car isn't just sitting in the driveway. It's an active part of a decentralized energy network. It's acting as a backup battery for your house, for your street, maybe even for your entire neighborhood during an outage. Okay, so let's jump into this second phase, from 2036 to 2045. This is where things start to get really interesting. The whole energy landscape begins to fragment and decentralize, as these incredibly powerful new technologies, stuff that used to be pure science fiction, start to become real.
This next decade is just packed with these huge technological leaps. We get next-gen geothermal, where we can drill deep and tap into the Earth's heat literally anywhere on the planet. We see the first successful tests of beaming solar power down from satellites in orbit. And then in 2040, the big one arrives, the moment fusion energy becomes a net positive reality.
Let's just pause on this for a second. The historic spark. This is the moment a fusion reactor, which is basically a tiny artificial sun in a box, produces more energy than we had to put in to get it started. This is the scientific breakthrough that proves a future of near-limitless, totally clean energy isn't just a dream anymore. And once that promise is on the horizon, society really starts to change. This new world of surplus energy starts to solve other massive problems, like powering huge desalination plants to end water shortages. A true internet of energy starts to pop up, where you can sell the extra power from your rooftop solar panels directly to your neighbor using blockchain. The whole landscape of our cities changes. Gas stations, they start to look like relics.
And that brings us to the final, climactic act of this whole transition, the dawn of fusion. This is where humanity basically graduates. We go from managing scarcity to managing abundance, finally harnessing the power of the stars right here on Earth.
In this final decade, the world fundamentally transforms. By 2048, the very first commercial fusion plant is connected to a national grid. By 2050, we start experiencing what you could call free energy moments. And by 2052, energy poverty is, for all intents and purposes, eradicated as a global problem. We are right on the cusp of becoming a totally new kind of civilization.
And by 2050, this leads to something that's honestly hard to wrap your head around. During peak production times, think of a sunny, windy summer afternoon. The sheer volume of energy being generated by solar, wind, and fusion is so enormous that its actual cost, in some places, literally drops to zero. That just completely rewrites the rules of economics.
You see, this whole journey is leading toward an ultimate goal, getting close to what scientists call a Type 1 civilization on the Kardashev scale.
And what that means is a civilization that has successfully harnessed all of the energy available on its home planet. Energy is no longer a scarce resource that we have to fight over, it's just a utility, like water from a tap.
But a change this massive doesn't happen in a vacuum. A complete transformation of our energy system means a complete transformation of global power. This is what's being called the geopolitical energy shock.
And here's how the model sees this new global chessboard playing out. You've got Asia pushing for total energy independence by mass-producing nuclear reactors and racing to master fusion. Europe builds the world's most interconnected, ultra-resilient smart grid. North America goes for a hyper-capitalist model, which creates a really modern but pretty unequal system. Africa brilliantly leapfrogs all the old, clunky infrastructure to become the world leader in decentralized solar. And South America? It becomes an economic powerhouse by supplying all the critical minerals like lithium and copper needed to build this new world.
So, after seeing this entire 30-year roadmap, how should we think about this monumental challenge we're facing? Is it some kind of doomsday clock ticking down, or is it something else entirely?
Well, the source material offers this really powerful perspective that maybe we are not, in fact, headed for ruin. Maybe what we're in is a growth crisis. That all these immense challenges, climate change, the energy transition, are really just the growing pains of a civilization that's leveling up to a more advanced stage.
Which leaves us with one final provocative question to chew on. If this prediction, or something like it, actually comes true, and we achieve an era of near-infinite clean energy, does that actually solve all of our problems, or does it just unlock a whole new set of challenges for a newly minted Type 1 civilization to figure out? What comes next?